Okay, guys, welcome to day one of e-learning. Today we're going to do a video and some problems. Okay, so what you're going to need is just your notebook paper, and then you're going to need packet 3. Okay, you'll also need packet number 3. But we're going to go to packet 3 in a minute. First, I just want to start. We are going to do be doing substitution, and this is from lesson 5.2 in the text book. Okay. So I'm just going to do one problem from the book. I want to do problem 15. That's on page 212, okay, of your textbook. And I will write the problem, though. You don't need to get your textbook out. We are going to have 8x minus 1/3 y equals 0. And we have 12x plus 3 equals y. Okay, so hopefully you recognize in substitution that you want to isolate a variable. And you can see that this variable is already isolated. So we're going to plug this in, the 12x plus 3, plug it in for y, okay? So we've got 8x minus 1/3 times 12x plus 3 equals 0, okay? And now it's just a matter of distributing. Okay, so we've got this and this. We have 8x minus 4x minus 1 equals 0, okay? I'm going to combine my like terms. I've got a 4x minus 1 equals 0. I'm going to add 1 to both sides. I get 4x equals 1, and I get x equals 1/4. Okay, so that's my first part of my ordered pair solution. Okay, now, if you recall, we're going to take this answer and we're going to plug it in to one of our two original equations. It doesn't matter which one. Okay, so I think the second one looks easier. So I'm going to go ahead and say, switch colors, mix it up a little bit. 12x, 12 times 1/4 plus 3 equals y. Okay, I just plugged it into my second equation. I took this and I plugged it in to this equation up here. Okay, so 12 times 1/4 is 3. So y equals 6. Okay, so my answer, my solution, is going to be 1/4, comma, 6. Okay, and we're going to go ahead and we're going to do our check. And our check entails filling my x and my y in to both of my original equations and making sure that we have a true statement. So I've got 8 times 1/4 minus 1/3 times 6 equals 0. That's going to give me 2 minus 2. That side checks. Now we'll do my second equation. We've got 12 times 1/4 plus 3 equals 6. That's 3. So it does in fact check. Okay, so there's one problem for you. Let me just look at my notes and see what I want to do next. Let's go to, let's do another one. Okay, flip your page, another clean piece of paper. Flip this out of the way for you. And I want to do another problem. Let's do, oh, let's see. And this is just a made-up problem. You can't find it anywhere. I'm just making it up. Y equals negative 6x minus 3. And y equals 5x minus 14. Okay? Now, the good news about this problem, and we have to isolate the variable, right? So we can plug it in, is that the y's are isolated in both of these problems. Okay? The y's are isolated in both of these problems, which is nice, which means we can set equal to each other. Okay? So I'm going to take negative 6x minus 3, and I'm going to set it equal to 5x minus 14. Okay, now I'm just solving. Let's see what we get here. I'm going to subtract 5x from both sides. I get negative 11x minus 3 equals negative 14. Okay, I'm going to add 3 to both sides. Negative 11x equals negative 11. I'm going to divide by negative 11. I get x equals 1. Okay? Now that I have my x, I'm going to take that, I'm going to substitute it back in to one of my original equations. It doesn't matter which one, and they both look about the same to me. So I'm going to take my first one, y equals negative 6 times 1 minus 3. And I get y equals negative 9. Okay? So my answer, or my solution, I should say, is 1, comma, negative 9. Okay, I'm going to check these. I go to my original two equations. Y equals negative 6x minus 3 and y equals 5x minus 14. I'm going to plug, this is x, this is y. Sorry, this is hard to see. I will move that around. There we go. I've got a negative 9 equals negative 6 times 1 minus 3. Negative 6 minus 3, negative 9. Awesome, that one checks. Let's do the other one. We've got a negative 9 equals 5 times 1 minus 14. That's going to be negative 9 equals negative 9. And we check. So we are good to go on that one as well. Hopefully you're getting a hang of these problems, okay? Let's see. Let's do one more, okay? Let's go to another page in your notebook. I just want to do one more example. We've got, let's see. Let's do x plus 3y equals negative 9. And let's do negative 5x minus 8y equals 10. Okay? It would help if you could see. Let's move that back a little. There we go. Okay. As you can see here, we need to isolate a variable. And this, I hope you recognize, this x has a coefficient of 1. So that is the variable that I'm going to want to isolate. So I'm going to take x plus 3y equals negative 9. I'm going to subtract the 3y from both sides. And I get x equals negative 3y minus 9. I now have an equation with an isolated variable, which in this case is the x. Okay, it's okay. It doesn't matter if it's y. It can be x as well. I'm going to take my second equation, okay, which is negative 5. Oh, I have an x. Those match up. So I can substitute this in for x. I've got negative 3y minus 9 minus 8y equals 10. So now I'm solving for y, okay? We're going to use the distributive property. I've got 15y plus 9 times 5 is 45 minus 8y equals 10, okay? I'm going to do some like terms here. 15 minus 8 is 7y plus 45 equals 10, okay? Subtract 45 from both sides. I get 7y equals negative 35. Let's move this up so you can actually see. Divide by 7. I get y equals negative 5. Now keep in mind, this is the y value. So for our solution, my y value goes here, right? So now I need to plug that into one of my original equations, okay, original, and solve. So here we have y equals negative 5. So I'm going to go up and I'm just going to pick the first one for no reason, oopsie, other than it just looks like an easier one. So I've got x plus 3y equals negative 9. I'm plugging in for y here. So x plus 3 times negative 5 equals negative 9. Okay, and I'm going to add 15 to both sides. And I hope you see that x equals 6, okay? So we've got 6 comma negative 5. And if you'd like to check, let's check it. Can't hurt to do a little check here real quick. Okay, we're going to do, this is my x, this is my y. We've got 6 plus 3 times negative 5 equals negative 9. Oopsie, 6 minus 15 equals negative 9. Well, that one checks nicely. Good. My second one is negative 5 times 6 minus 8 times negative 5 equals 10. Let's see, we've got negative 30 plus 40. Oh, look at that. Works out just perfectly, okay? So there's some good examples for you when you're trying to learn the substitution stuff, okay? Let's do just a couple of word problems, okay? So now I want you to put that aside, and I want you to get out your packet number 3, okay? And we are going to do, let's see, let's go to note packet 3, and let's go to page 43, okay? Okay, it says, okay, we are on page 43, okay, of note packet 3. Okay, during a football game, the parents of the football players sell pretzels and popcorn to raise money for new uniforms. They charge $2.50 per bag of popcorn and $2 for a pretzel. The parents collect $336. Okay, they sell, here's the second part. So my second equation, they sell twice as many bags of popcorn as pretzels. We need to know how many bags of popcorn and how many pretzels do they sell. Well, the first thing I'm going to do is I'm always going to define my variables, okay? So my X is going to be my bags of popcorn, and my Y is going to be my pretzels, okay? And that's number of, okay? Now I'm going to write the equation or the system of equations that represent the facts presented in this problem in proper notation, meaning I have to have my bracket, okay? Now the first one's pretty easy. We know it's $2.50 per bag. So we've got 250x plus, oopsie, there's my x, plus $2 per pretzel, and they're going to raise $336, okay? Now my second equation is not as easy. They sell twice as many bags of popcorn as pretzels, okay? So twice as many bags of popcorn as pretzels. So we're going to have x equals 2y. And why that is that, you know, there's more, they sell more popcorn. So to get the popcorn to equal the pretzels, you have to multiply the pretzels by 2. Okay, that's how I think of it. Now we're going to solve the system using substitution. I hope you see that the x is already isolated. You have to isolate your variable. So we're going to have, I don't know why I have an x there. That's supposed to be a dollar sign, okay, and a dollar sign. Okay, we have 250 times 2y plus 2y equals 336. Okay, 250 times 2y, I hope you see that that is $5. So that's 5y plus 2y equals 336. I'm going to add my like terms. Divide by 7. And let's see what that is. 336. Get my calculator out. 336 divided by 7 is 48. So y equals 48, and that is y, so that's pretzels. Okay, I'm going to go ahead now, and I'm going to substitute that y in for one of them. I like the first or the second equation better, so I'm going to do x equals 2 times 48, okay? And you can see that that's what? 96 bags of popcorn? I can't spell. Okay, there we go. So my final answer, I'm going to put it, x goes first, and I'm going to use my labels, 96 bags of popcorn and 48 pretzels. Okay, good. And we are up on the 13-minute mark. I'm going to do just one more to make sure we're good, and then we will move on. Let's go to page 41. Flip back to page 41. Okay, so we're on page 41 here, and we are going to do number 2, which is a store, number 2, packet 3, page 41. Okay, a store sold a total of 125 car stereo systems and speakers, okay? So a total of 125 for both of those. The stereo systems sell for $104.95 each, and the speakers sell for $18.95 each. The sales from these two items totaled $3,658.75. Oh, look at those numbers. Okay, how much of each item is sold? Okay, well, we should always define our variables first. Our x, let's just go in order, is car stereo systems. That's number of. And we'll say that y is number of speakers. Okay, we're going to write our system in proper notation. Now this one isn't so bad, guys. Think about it. They have 125 car stereo systems and speakers. So it's a combination of the two. If you add those together, you're going to get 125. Okay? Now, they say that a stereo system sells for $104.95. So $104.95 times some amount of stereo systems plus $18.95 for a speaker times some number of speakers is going to give us $36.58.75. Okay? And now it's just a matter of putting this into using substitution to solve. Okay? Now I need to isolate a variable. And I hope you see that on this one, it doesn't matter which one I do. They're both coefficients of 1, so I can do either. So I'm going to do x plus y equals 125. I'll subtract x. Y equals negative x plus 125. Okay, I'm going to substitute that in now. So I've got 104.95x plus 18.95. Well, these are messy numbers. Negative x plus 125 equals 36.58.75. You can absolutely use your calculator on this one. Okay, we're going to use the distributive property. No, that's going to be a minus 18.95x plus, let's take 18.95 times 125, and we get 23.68.75. Okay, I'm going to combine my like terms. Okay, let's see. We've got 104.95 minus 18.95 is going to give me 86x. Okay, plus 23.68.75 equals 36.58.75. I'm going to subtract from both sides. I get 86x equals, again, just use your calculators, 36.58.75 minus 23.68.75. You get 1290. Let's hope that goes in nicely. Divide by 86, divide by 86. It does. X equals 15. So we know that one of my answers is going to be 15, or I'm sorry, the X value is stereo systems. Okay, now we need to find my Y value. I'm going to plug that in. X plus Y equals 125 is way easier. That's 15 plus Y equals 125. And we get Y equals 110. So we have 110 speakers. Okay, I hope that helped. There's going to be a few problems, and then you're good to go. I hope that helped, and I will be back with you in a few days.